Hello and welcome to some calculus tutorial. Today in class we were taking a look at function analysis, looking at a function and its derivative, the slope function, and how they relate to each other. If you know one of them, that tells you something about the other. And one of the big challenges of this class is precisely describing what you do know about the derivative or what you do know about the function without getting them mixed up. So first we're going to take a look at the relationship between a function and its derivative f prime. So I like to draw two graphs for this. So we're going to have our function f. I'm going to draw a graph here. And then next to it are f prime. We'll draw a graph right next to it. And so we can kind of look between the two here. And so remember, f prime is the slope function. It tells us about the slope of the original function f. So if my function for f, let's say, looks something like this, how can we describe that function f? Well, that function is increasing. And if a function is increasing, you know something about its slope. The only way a function can be increasing is if the slope is positive. That means you will be going up. You have a positive slope. So I'm going to put a little plus sign over here underneath f prime. So if my function is increasing, that means f prime must be positive. Now, do I know exactly what f prime looks like? Right now, no. I just know that it has to be positive. It has to be somewhere up here. Okay? It has to be positive. In this case, the main characteristic is above the x-axis. That is where all your positive numbers are. It must be above the x-axis. Alright, let's do another simple one here. What if my equation looked something like this? Now the equation, or the graph, is going down, which means the function is decreasing. Well, if your function is decreasing, that means the slope must be negative, which means my derivative then must also be negative. So where would that graph be? I don't know exactly what it looks like, but I do know that it must be down here somewhere. Okay? It must be negative, or in this case, below the x-axis. Okay? And so we sort of see our relationship here. If our original function is increasing, the derivative will be positive. And if our original function is decreasing, our derivative, f prime, must be negative, because we are talking about slope functions. All right, so that gets us the relationship between f and f prime. Now we want to use that relationship. If we are given the derivative, can we describe the original function? And then we're going to do that backwards. If you're given the function, can you describe the derivative? So let's start with, given the derivative, can we find or describe the original function? Alright, so here we are given f prime. This is the derivative. can we describe the original function? All right, so I'm going to click up here, draw my two graphs. If this one is f, this one is f prime. And the relationship I know is that if f is increasing, then the derivative must be positive. And if f is decreasing, the derivative must be negative. And so right now I am given the derivative. So as I describe this function, these are the words I want to use. I don't want to use increasing or decreasing because I don't have the original function. I have the derivative. And so that's where I'm going to start. So using positive and negative, how can I describe this graph? Well, at first, let me get my highlighter back. From here to here, as I'm going along, the word I want to describe with this is positive. Now I know you're really tempted to use the word decreasing, but I'm not allowed to use that word. The only word I can use to describe this is positive because I am above the x-axis. So, when x is less than 6, the derivative, f prime, is positive. So, what does that tell me? Well, that tells me the original function must be increasing. So f must be increasing. Alright, and going from there, after 6, how am I going to describe the function down here? Well, now the function is negative. I know we still want to say decreasing, and yes, it is decreasing also, but I can't use that word to describe it. I can only use these over here. We are negative below the x-axis. So when x, sorry about that, my doorbell rang. So where were we here? We are taking a look at when x is greater than 6. Oops. So what do we know when x is greater than 6? This function is below the x-axis, so that means it is negative. So f prime, actually let me color code this a little bit better for you, When x is greater than 6, f prime is negative. So f of x must be decreasing. So that means our function is increasing and then decreasing. Do we know exactly what it looks like? Right now, no. But if I were to draw a general increasing and decreasing function, it's going to be something increasing. And then right here, I have to switch from increasing to decreasing. So I'm going to come down like that. It's probably some kind of parabola. But again, right now we don't necessarily know exactly what that looks like. All right, so we are able to now describe a function given its derivative. We have to try to go the other direction. We are going to go, if we have the function, can we then describe the derivative? I think this one for many people is actually easier. All right. I'm going to keep my graphs up here on the top right because we're going to use the same idea only we're going to go backwards a little bit. So this time we're given the function g of x. Use a different letter here so we don't get too confused, but same idea. This is our regular function. So we are going to be looking at, oops, I don't want to use red. Let's use green. Now green won't work either, will it? Let's, whatever color this is, yellow. Now we are given f of x, the original function. So what words am I allowed to use to describe this? Increasing and decreasing. So I'm going to start with my function down here. What word can I use to describe the function here? We are increasing, and I have to stop right there because if I kept going, we would start to decrease. So, first off, I don't really have a yellow, sadly I'll use black. So let's see, that is when x is less than, now here we're going to have to estimate, let's call, this is about negative 1.5. It's not exact, but I'm not too worried about being exact right now, just the concept. X is negative 1.5. We know that f of x is increasing. So that means that the derivative f prime must be positive. All right, it's using this exact same relationship here that we used before, only in a different direction. All right, let's do continue along the line here. If I keep going from here, now the word I have to use to describe this function is decreasing, and we are decreasing all the way to here. That's where that will change. So let's see. Actually, I have it right, don't I? Got to get a little fancy with my inequality signs here. When we are larger than negative 1.5, but smaller than, that looks about like 2. Again, we're estimating. It's probably not exactly 2, but I want to make sure we have the concept. So that interval there, our function is now decreasing. So that means our derivative must be negative. And last but not least, let's use blue, I suppose, from 2 on up. All right. We are again increasing for our original function, which means our derivative is positive again. So you're going to write another sentence just like this one. I'll let you do that. I don't think I need to. But when x is greater than 2, I can start it off for you. When x is greater than 2, and you can finish that sentence off, g is increasing. That means g prime is positive. All right, so we've taken a look at a couple of things here. Oops. There we go. Let me erase all this off. For function analysis, mostly when a derivative is positive, that means your function is increasing. And when a derivative is negative, your function is decreasing. And you want to be able to take that logic in both directions, from f prime to f, or from f to f prime. Both of those are very important. All right, hopefully that helps. I'll talk to you later.